Hello everyone and welcome back to Modern Software Development and IT from Code to Cloud. I'm Maria Kalendarova and this is episode 2. Last time we explored how microservices and containers are changing software architecture forever. Today we'll be completing this picture by diving into where all of this software actually runs and how teams manage it at scale, ensuring that everything runs smoothly and efficiently.
That's right, Maria. I'm Hristo, your tech host. If episode 1 was about the build and package software, today is about where we run it and how we manage the entire lifecycle. We'll talk about the infrastructure revolution that helped companies like Spotify to grow from a tiny startup to a global platform. Plus, how DevOps culture turned software delivery from a monthly headache into a daily seamless routine. It's about going from idea to impact faster and more reliable than ever before.
All right, let's begin with the cloud. Everybody uses it, but what does it really do? What does it mean?
Good question, Maria. Think of a cloud as a massive global network of powerful servers and data centers delivering everything from compute and storage to tools over the internet anytime you need and you want. People often say the cloud is just someone else's computer. And while that's technically true, it misses the big picture. It's not just a computer, it's a vast, professionally managed infrastructure that you can spin up on demand, scale almost infinitely, and most importantly, only pay for what you use. That's what makes the cloud more than just a tech trend. It's a fundamental shift in how we build and run software.
Okay, so it's not about one new technology. It's more about a new way of use and pay for compute power and other resources like storage.
Exactly. The cloud is the latest and arguably the most game-changing evolution in infrastructure chain. Before the cloud, launching a startup meant buying servers, renting spaces, hiring system administrators, and hoping you're guessing your traffic right. Guess too low, your apps crashes. Guess too high, you waste money on idle hardware. The cloud flipped that script, and platform like Azure let you launch globally in minutes, scale automatically, and pay only for what you use, as we said. It's a whole new way to innovate.
That sounds terrible for early startups, actually. Did companies really fail because of scaling?
Absolutely. And Friendster is a classic example. They struggle with scaling, and it opened the door for Facebook, which nailed the scale infrastructure early on. In 2006, Amazon Web Services launched, and AWS started offering their infrastructure into a service anyone could rent and use it by hour or minute. Suddenly, you could scale from one server to thousands and pay only for what you used. Microsoft followed in 2010 with Azure, focusing on enterprise hybrid cloud solutions. They didn't invent the cloud, but they brought it big into the enterprise world.
So, overnight, a small startup had access to an infrastructure that giants did.
Precisely. Overnight, a college student or a tiny startup with only a laptop had the same access as world's Fortune 500 companies did. That democratization fueled the startup explosion we've seen in the last 15-20 years.
Um, I hear acronyms like YAS, PAS, and SAS all the time. Can you break those down in a way that's easy to remember for us?
Sure. Let's take a housing analogy. Infrastructure as a service is like renting an empty plot of land. You get the basics, but you build the house yourself. Maximum control, maximum responsibility. In Azure terms, that's Azure Virtual Machines. You get the virtual machines, configure network and storage, and you are responsible for updates, scaling, and security afterwards. Platform as a service is like renting a furnished apartment. The one word handles maintenance. You just move in and leave. On Azure, that's Azure App Services or Azure SQL Database. You focus on your application or data. And Azure takes care of underlying infrastructure, operating system, and scaling. And software as a service is like staying at the hotel. Everything is ready and take care of you. You just enjoy the stay. Azure software as a service offerings includes Microsoft 365, Dynamics 365, and Power BI, for example. You just sign in and use the service. No infrastructure, no deployment, and no patching. Cloud offers all these options depending on how much control and responsibility you want.
Could you please give us any real-world examples of how a company could use these models in practice?
Spotify is a great one. They handle hundreds of millions of users that's streaming music worldwide, especially during big releases. They use Azure Virtual Machines for streaming, but lean heavily on Azure AI services for recommendations like Weekly Discover. They only pay for what they used and scale globally in seconds and free their engineers to build features, not babysitting their servers. When you press play, Azure Global Data Centers deliver the music closest to you, while AI is already guessing your next favorite song.
Okay, what about hybrid or on-premises setups? Why don't all companies just move everything to the cloud?
Let me give you a different way of think about it and use transportation analogy this time. On premises is like owning your own car. You have full control, but you're also responsible for everything from maintenance, insurance, upgrades, and repairs. That's why industries like banking and healthcare prefer it over compliance and data privacy. Public cloud is like using Uber. No maintenance, no overhead. You just request what you need and go. It's fast, scalable, and efficient. Companies like Spotify choose it for its agility and global reach, as we mentioned. A hybrid cloud is like owning a car for your daily commute, but calling Uber or taxi when you travel in another country. You keep core systems on premises for full control, but the cloud you use for things like customer-facing apps, seasonal demand, or global access. Microsoft designed Azure with hybrid in mind because enterprises can't flip a switch overnight.
So we have this powerful, flexible infrastructure, but spinning up thousands of servers sounds a little bit complicated. How do teams manage deployments?
That's where the DevOps shines. DevOps isn't just a job title or tools. It's a culture and a mindset that breaks down barriers between the development and operation teams. DevOps says, let's work together, automate everything, and make deployment routine safe and fast.
So DevOps is more about culture than than specific technology.
Exactly. Tools support culture, they don't create it. DevOps principles are all about collaboration, automation, continuous improvement, short feedback loops, and psychological safety. So teams learn and grow instead of blame.
So how does DevOps philosophy solve this?
DevOps basically asked what if development and operations weren't separate kingdoms constantly at odds, but instead work closely together throughout the entire software lifecycle, from idea all the way to the production and back. DevOps unifies development and operations, as we said, to make the software delivery smoother and more consistent. The core principles are collaboration and communication, automation, continuous improvement, short feedback loops, culture of learning, and psychological safety. once again. It's a cultural shift and mindset that's transformed how we build and earn software. I know I said it, but yeah, I just want to really point it out.
Another thing that I hear quite a lot is CI/CD pipeline. Can you simply explain that?
Yeah, sure. Sounds complicated, but CI/CD stands for continuous integration and continuous delivery, or deployment. And we'll see the difference. Imagine a developer writes a new feature. Continuous integration means that every code change automatically triggers a build and test process. That the idea is to catching bugs early and to check the code. Continuous delivery, package code so it's ready to deploy with one click. And continuous deployment goes even further by automatically pushing changes to the test or even production environment after a test pass. So the pipeline looks like this. We have the developer who write the code. Code is committed. We have the build. After that, we have the test phase, deployment to staging, more tests, deploying to test or production environment, and we have the monitor phase. This cycle, once for weeks or months, now happens in minutes or hours.
Deploying so often sounds scary. Doesn't that increase the risk?
Counterintuitive, but no. Frequent small changes reduce the risk. Companies like Spotify that we mentioned deploy code every few seconds, deploying hundreds of times a day. Small changes mean you spot problems fast and you can fix them quickly. Now DevOps teams have fewer production failures and recover much faster than before.
It seems to me that DevOps treats infrastructure like software.
You're right, Maria, and that's the infrastructure as a code. Instead of manually provisioning and configuring servers and other infrastructure resources, of course, you write code that describes your infrastructure. The code is versioned, tested, and run to create consistent environments automatically. Infrastructure as a code prevents snowflake servers and configuration drift. It makes disaster recovery easier, testing simpler, and infrastructure reproducible, just like the software. Infrastructure as code turns infrastructure from a fragile, manual mess into a well-oiled, automated machine.
Can you tell us what does it take to turn code from a developer's machine into a production app that is running at scale in the cloud?
Okay, so here's the idea of the life cycle. Developers write microservices code, package it into containers, and push it to a version control that triggers CI/CD pipeline that we mentioned, which build containers running tests and storage images in a registry afterwards. Infrastructure is defined as code managed by orchestrators like Kubernetes that handle deployment, scaling, and monitoring automatically, which we'll cover in the next episode. It's an ongoing cycle of building, deploying, learning, and improving. That's what we call the cloud native development, designing apps to fully leverage the cloud's agility, resilience, and scale.
It really feels like these pieces, the microservices, the containers, what we talked about the last time, and now the cloud and the DevOps are designed to work together, not separately.
Sure thing. They are tightly integrated and reinforce each other. Cloud gives elastic infrastructure, microservices and containers provide agility. DevOps is the glue that makes software delivery fast, safe, and repeatable. This combination is powering nearly every modern digital experience, from Spotify to Uber to your banking app.
What a journey! We've gone from monoliths on physical servers with infrequent risky releases to cloud-native systems that deploy code safely every day.
And we're just getting started. The future is about serverless, edge computing, GitOps, chaos engineering, and AI-driven ops. The next wave is already forming.
Thanks for joining us today on Modern Software Development and IT from Code to Cloud. Subscribe for deeper dives into the tech shaping our world today. If you're building systems that scale and evolve, stick around. The next wave of innovations starts with the foundations we laid today.
Well said, Maria. Until next time, and follow the DevOps principle. Fail fast, run faster.